The topic of this lecture video is friction and wear, which are both central concepts to the functioning of macroscopic machines. Friction is the force F opposing movement between two surfaces. It reduces the force available to do useful work and defines the minimum force which has to be exerted by the driving force. Dry friction is also distinguished from wet or lubricated friction. In general, when it comes to friction, Amonton's law has been found to be typically true. Amonton's law states that the force, the friction force, is equal to the friction coefficient times the normal force. Mu depends on the material structure and the material combination, but surprisingly, it does not depend on surface area or surface roughness. Mu is unitless, and for dry synthetic material, it has typical values between 0.01 and 1. However, in joints, the friction coefficient can go as low as 0.01, which is 10 times smaller than the usual values for dry synthetic materials. Furthermore, the presence of a film of lubricant can reduce the friction coefficient more than tenfold. And the work done to overcome friction is primarily dissipated as heat. Wear, on the other hand, is the process of removal of material from sliding surfaces. In the image that you can see here, the distinction between friction and wear is described. In the upper images, you can see 3 different types of friction a material can be experiencing. Whereas in the bottom images, you can see that the wear mechanism always involves some kind of material removal, just like we said. And interestingly, more friction does not automatically correspond to increased wear. For instance, Teflon, or PTFE, has low friction but a very high wear. To describe wear, the following equation can be applied, where V is the volume of removed material, P the applied load, V the gliding velocity, T the time, and K is a constant that is typically between 1 and 1,000 times 10 to the minus 6 millimeters cubed per Newton meters. And just like for friction, lubrication dramatically reduces wear. Wear is often highest when 2 parts are initially brought together, and this is called the run-in period. You may have heard this when it comes to driving a new car, for instance. But after the running period, the wear declines significantly, and we say that the 2 surfaces have adapted to each other. Wear interferes with machine operations by increasing the tolerance of parts, or this is also called rattling. It weakens parts and removes protective layers, but it can also generate wear particles which can be detrimental, specifically when it comes to implants that are inside the body. An example of which can be a metallic hip replacement that wears out and generates metallic wear nanoparticles inside the bone in which it is inserted. Thank you for your attention.